everyone. Thank you for joining the conference. And today I'll be speaking about event-driven scaling with KEDA and AKS because obviously we are talking on Azure today. So just a brief introduction about myself. My name is Ronak Banka, and I'm part of VMware Singapore. I work here as the Senior Solutions Architect, and I've been working in whole cloud and containers for almost over 8 years now. And in part time, I love cooking. So I love cooking, trying out different cuisines. And if you want to follow me on Twitter, that's my Twitter handle. If you want to check out my blog, you can check out the blog as well. Okay. So when we are discussing about like AKS and all the event driven and other like fancy words, there are obviously a lot of knowledge out there, but today we'll just focus on this agenda. So we'll discuss why we need auto scaling, what are scaling options are there in Kubernetes. So while I was watching Sayam's video, I saw like few people commenting that there is no session for introductory Kubernetes, but I think maybe we can take a minute or two during this talk. So we'll discover what all scaling options are there in Kubernetes. Then we'll go to what is actually KEDA and how we can use it. Then we'll see that what is the KEDA architecture looks like. So what are main components of that whole system and how it works. And then finally, we'll go to the demo where I'll show how to actually deploy a function on AKS, and then we can scale using KEDA. And then at the end, question answers if people have any questions. So why auto scaling? So when we talk about containers, when we talk about all the cloud native technologies, one thing very common is the scale. So those platforms gives us a lot of flexibility to configure our systems in a way that they can actually auto scale by themselves. Someone doesn't have to go there in person and then like scale up your system. So for example, if some organization is having like $1 billion sale or some other super sale, they don't want people to just sit there and scale things manually while a lot of people are actually trying to access your marketplace or whatever product you're offering. Uh, so then we require the auto scaling. So auto scaling helps us to scale up and scale down our system based on few like metrics or based on a few different events, which today we'll explore. So why we need auto scaling? So if you look at this slide, uh, this is actually like a house burning. You can consider it more of a, like, you can say, not exactly an organization, but more of an event, something like sale or something like that. People say, okay, we don't need auto scaling, but then when you have like thousands and like lakhs of user accessing your marketplace, things started crashing. So you will see a lot of your systems are crashing because you were not actually prepared for that kind of load on your systems. You were not prepared of that kind of traffic. And that's where the whole point of auto scaling comes in. It helps us to basically configure our system in a way so that we can be prepared for unexpected scenarios. So don't like treat auto scaling like you don't need it. You surely need it. It's just that you will need little bit practice to be more confident on these things. Now, what all scaling options we have in Kubernetes? So I'll just give like a very maybe a minute overview of what is Kubernetes. So for those who are not familiar with what is Kubernetes, it's basically a container orchestration platform which gives you like all the building blocks on top of it, on around it, to create a mature platform, to create a mature system for your organization, which can scale in itself, which can actually integrate with a lot of your enterprise systems, or more you can say like some of the legacy systems. Um, when we talk about scaling in Kubernetes, there are different ways where we can actually scale our systems. So before we had all these event driven and like fancy scaling options. There were like very limited options in Kubernetes. So these were like very few options. I mean, these are few options which are available now. Obviously, we have the manual scaling, which was there from the very starting. We have something known as horizontal pod autoscaler, which helps to autoscale your Kubernetes pods based on few metrics, but those metrics are limited out of the box. Then third is something known as virtual nodes. Virtual nodes, we'll discuss what it is in like maybe a brief overview, but then virtual node helps us to like scale your infrastructure, not exactly infrastructure, but basically your application scales. And then last, we have the event-driven scaling, which today we'll discuss about. Okay. So let's move to the first one, which is actually the manual scaling. When you deploy an application on top of Kubernetes, this is like the easiest way, or like this is the very, you can say, a noob way of doing scaling, even though it's not very effective, because it depends on human action to scale the application. I mean, for sure, you can basically plug in the GitOps and all, but then again, someone has to change those numbers. Someone has to change that configuration so that Kubernetes can actually scale up your application. And when we talk about manual scaling, it's basically done using simple kubectl command. So you can just give kubectl scale, your deployment name, and tell how many replicas you want to run. So for example, if you are running one replica, you want to change it to two. So you can just run the simple command, which is there on the screen. Um, Similar options can be done for scaling your cluster as well, but that's using like Azure CLI, AZ CLI. You can scale your clusters using the CLI, but again, it's a manual step. The second one is the horizontal pod autoscaler. This is more advanced from manual because this type of scaling depends on some system metrics to scale your application. If you are running your application and you want to auto scale your application in case your CPU percentage goes by 80%, you can actually configure that using HPA. You can say that kubectl auto scale your deployment name. You can say how many maximum number of pods I want. I don't want to go beyond this number because maybe you don't have enough capacity, or maybe because you have like tested your application to like manage or to handle that much traffic. And then you basically give your the CPU percentage, which defines that, okay, if my CPU percentage is more than 80%, then just auto scale my deployment. Um, One of the limitation of HPA is out of the box, they're like very, you can just like scale by CPU percent. So they are like limited metrics on which you can use HPA. So we look into how the event driven scaling is helping us along with HPA to create a more dynamic system. The third one is the virtual nodes. So this is again the virtual node. It implements something known as virtual kubelet in AKS cluster. Virtual kubelet is an open source project, but then there are like a lot of different providers who are supporting it. For Azure, it's Azure Container Instances. So, for example, when you're running your application platform, you're running a Kubernetes cluster, and you have integrated with ACI. When you have actually like when you have more traffic and you don't have enough infrastructure on your cluster itself, virtual nodes helps you to scale your application on something known as, again, it's called by the name virtual nodes, which is not part of your infrastructure. It's basically it's provisioned by like Azure itself in your own network. So it looks something like this. You have your AKS cluster, and then you have your ACI instances. You can say Azure Container Instances. Um, when you have a lot of traffic on your main cluster, what it does is that it actually bursts your application. It moves your application to the ACI. So it runs the pod on those ACI instead of running on your cluster. So this is again like a different implementation of how you can use ACI. And the final one, which is the event-driven scaling. So this type of scaling can actually use a lot of different metrics from different sources. So we'll be focusing on this one today. Like in the backend itself, the event-driven scaling, or I mean, in our case, KEDA here, it uses the horizontal pod autoscaler itself, but then we'll see how it actually utilizes the HPA in backend. And then, sure, it can be used in combination with virtual node. So if you have if you have to scale your application on your Kubernetes cluster, you can integrate event-driven and virtual node. So under certain circumstances, it will basically burst your application on ACI. Okay. Okay. So main topic for today, what is KEDA? So KEDA stands for Kubernetes-based event-driven autoscaler. I mean, yeah, it was easy to like create a short form for that. So what does event-driven autoscaler actually does for us? So how does KEDA works is it works alongside your standard Kubernetes component, for example, HPA, and it extends the functionality without overwriting or duplication. So in for KEDA, when you deploy this architecture, when you deploy this component in your Kubernetes cluster, it basically exposes additional metric API, which can be used with HPA. So for example, when you deploy KEDA, it's an operator, it's a Kubernetes operator. So it has two major roles. One is the agent, and the second one is the metrics. So what is the role of the agent? Agent helps the cluster to actually activate and deactivate your Kubernetes deployments to scale to and from zero, or like how many like pods you want. So it again, if you see, it's not actually doing outside something. It's basically like extending the functionality in your cluster itself. And the second role is the metrics. So KEDA acts as a Kubernetes metrics server, which exposes like event-driven data, which exposes the event data from different sources, and that can be actually used by HPA. So you are still running you still have the horizontal pod autoscaler. It's just that the backend API which it is using, it can use from KEDA. So it exposes that because it has more richer format, or it can integrate with more sources for your metrics. Okay. So this is like a very I mean, this diagram is from the KEDA website itself, but this is like a very overview of the architecture for KEDA. So obviously we won't go in deep, but we'll just look at the very basic components which are actually responsible for all the work inside your cluster. So obviously we know that on top we have the Kubernetes API server, and then the big blue box is actually the KEDA. So it has three components. One is metrics adapter, the second one is controller, and the last one is scaler. Scaler is responsible for communicating with your external sources. So we'll see what all sources it can integrate with. Scaler is responsible to present the metrics from external sources to HPA. Then the second component we have is the metrics adapter, which in itself is actually it's an API which integrates with HPA. So you have your scaler, then you have your metrics adapter. Now someone needs to take care of the whole loop situation, or in Kubernetes term like reconcile loop, which is managed by controller. Controller is responsible for managing all the objects which are created for KEDA itself. So they are like different CRDs which are exposed by KEDA. And when we create them, our controller is responsible to take care of those CRDs or the objects. Um, the most important thing over here is the scaled object, which is like on top left. So scaled object, it actually defines the mapping. So you have an external source. Now you have your application. So scaled object defines your mapping between your actual deployment and between the trigger source. So we look into the example, what does the scale object looks like. Yeah. Okay, so KEDA scalars. This is one of the best thing which I like about KEDA is basically the number of scalars it can integrate with. So it can integrate with your queues, it can integrate with your analytics tool, it can integrate with your Kafka, MongoDB, MySQL, Prometheus, Redis. So there are like a lot of connectors which you can use with KEDA. So today we'll actually look into how we can use the Azure queue, so Azure Storage Queue in our example. Okay, most exciting thing, demo time. So before we actually go on to demo, let's do something which is pray to the demo gods, because demos are like the most scariest thing which can which can go wrong, like in any presentation, no matter like how many presentations you have given or how many like demos you have given, there is always like 99% chance for your demo to fail. So yeah, let's just pray to demo gods. So today I'll be deploying a Node.js application, a JavaScript application, which in backend uses, it's basically not an application, you can say it's more of a function. So it's a node function which in the backend integrates with Azure Storage Queue. And what will happen is that when we put a message into that queue, our function will, like our Kubernetes and along with KEDA, will be responsible to spin up our instance, which we'll look into the demo. Okay, so just give me a sec. Let me share my screen again. Oops. Okay. Okay. Akshay, can you see my screen, the terminal? Okay.
Yes.
Yeah.
Okay, great. Okay, so over here, let's do one thing. So what I've done is have already created a Azure Kubernetes cluster, because obviously it takes some time. So I don't want to waste that time during the demo. So I've already created the cluster here. So I've already created a cluster on AKS. You can, Microsoft obviously gives a very good documentation on how you can get started with the creating cluster itself. So over here, I've already created the cluster. Now what we'll be doing is, my cluster is already deployed. I've already created the kube config here, which is sitting in my folder itself. So I won't be doing cat on that, but I can just show that, okay, what does the cluster info looks like. So our cluster is running on Azure AKS. If I do duplicate nodes, I can see that, okay, I have my two like workers already deployed over there. Okay, now before we, so when we have to deploy an application on AKS, obviously you can use kubectl to deploy. So in our case, the first step is we'll be deploying the KEDA itself. So KEDA is a Kubernetes operator. So what I've done is I've already created a script so that I don't have to do everything at the same time. So we use Helm to deploy KEDA onto our Kubernetes cluster. So as of now, if we see that so for now, we don't have, oops. So we don't have the KEDA namespace. So what we'll be doing is we'll be deploying our KEDA over here. So it will basically add the repo. It will create the namespace. It will use the Helm chart to deploy the KDA operator in our cluster. Uh, Now, obviously, we won't be going in how operator works and all, but again, it's just basically like simple Helm chart, which deploys two component. One is the operator, and the second one is, one is the controller itself, and the second one is the metric server. So once this is deployed, we can see we have two pods running inside our cluster. So just give it a minute. Yeah, so now it says it has deployed. Oops. So let's see what we have in our, so if you see our namespace was created. Now if I want to get pods in KDA namespace. So we have two pods here. One is the operator, like the controller, and the second one is the Metrics API server. Metrics API server is, like I said, it's responsible to communicate with your HPA. Now, what we'll do is we'll see that, okay, we don't have any uh, deployments here. Oops. So we don't have any deployments in our default namespace. So today what we'll do is so the good thing about like Azure, so there is a Azure CLI which is provided by the organization, which is known as Funk. Funk is basically CLI to do all sort of things which are related to the functions. For example, you can create your functions using this particular CLI. You can actually even deploy your functions on Kubernetes using the CLI, which we'll do today. Yeah. So what we'll do is we'll create a function here in this repository where I already have the kubeconfig. And I'll use the Funk CLI to actually create my function here. So once I give this, it will ask me that what kind of worker runtime I need. So I'll be deploying a Node app, so a Node function. So I'll use Node, and then I'll use JavaScript in this case. So good thing about the CLI is it actually creates like Docker file and everything for you. So if we go to this one, KDA function app, let's see. So we have 4 files here. One is the Docker file itself. Which again, it's very basic Docker file from boilerplate, which creates your application repository and everything here. So now we have our function folder. Now what we'll do is I'll add a function here. So I'll just say func new, and it will ask me what kind of function I want to create. So I'll use like a template from Azure itself, which is using Azure Storage Trigger. So I'll use number 10, and I'll just name it Q trigger. So once I have this Q trigger, let's check what is the content of the Q trigger. So it creates a few files here. If you see, it creates your index file, which is nothing very simple. It's just processing your queue. And then you have your function.json, which defines that what you want to actually, like how you want to bind your queue over here. Yeah. So what we'll do is over here, I've already created a storage queue, but yeah, it's not obviously something very fancy. It's just like few. I'll just show you how I did that. So it's just like very simple commands of AZCLI. So it helps you to create a storage queue. Once you create the storage queue, you can actually get the connection string, which is required for connecting your function to your queue. So what I'll do is I'll just get my connection string. Yeah, I have to, like, I wrote scripts for everything because I'm very lazy at writing the code. So what we'll do is we'll just copy this string, and then we'll go to our app. So in our app, we'll define that string inside our storage. So once we define this in our storage, we need this metadata. So we don't have to worry about like creating everything by hand. For example, secrets and all those things. Those are actually taken care by the Func CLI itself. Uh, yeah, so I'll just quickly show. So yeah, we have configured our queue trigger. We have created like our connection string in the local setting file. Not what we'll do is we can actually deploy the app using the func CLI itself, and then so what I'll do is I'll just name it maybe hello AKS day. Yeah. So when I gave hyphen hyphen registry, it helps me to create the Docker image itself. So I don't have to do it. I just have to do a Docker login here. But for example, if you're trying to use a private registry, then you have to do some additional steps. So once I give this command, what it will do is, okay, I have given dry run. That's why it actually gave me the whole thing. So what we'll do is we'll actually do app.yml so I can make some changes. Okay. Oops. Add some additional values here so that, okay. So let's do one thing. Let's open this. So what you see at the bottom is actually the scaled object, which is responsible for scaling your application. So I'm configuring that, okay, my minimum replica count is 0, maximum is 5, and then what is the trigger? So whenever I will have an event in my queue, it will actually process that. Okay, can you tell how much time is left? Okay, so let me do one
Actually,
thing.
we are already like 6 minutes
Yeah,
behind.
okay. I started late, I guess. Okay, no problem. Just give me a minute. I'll just show one thing. So, so what I'll do is I'll just quickly apply this. So this will actually deploy it will create a deployment, it will create a scaled object. So if I do here get deploy, I can see that the deployment is already created, but there is no pod because there is basically zero requirement for now. So what I'll do is I'll put this on get pods. Oops, oops. Yep. So, and what I'll do is I'll just use my other browser to load some values in the queue. So I've created a script. So what I'm doing is I'm just like putting some values in the queue. And once we have those values in the queue, we'll see that in our pods will start creating because now we have some of our values in the queue. So see, uh, now when we have once our values are available in the queue, the trigger will, okay, image will back off. Why? Okay, let me check something. Okay. I'm not sure if I had Docker login. Data, sorry. Just give me a sec. Oops. Yeah, that's why I said demo gods thing. Okay, let's deploy again. So yeah, it is building my image. Yeah, I think that was the issue because I didn't log in. So that way it was not building the image. And then yeah, it started creating the container. But again, there was no image over there. So probably just take a minute. It will just deploy the app. Just a second, just give it a minute. So once the image is, so the good thing about the CLI is that you don't have to do all the manual steps of creating your images and like deploying separately. You can just use the CLI, which will do the end-to-end things for you. So, okay, let's just check. I'll just again apply this one because, no, okay, no problem. I'll just show that one. Come on, demo gods. These things already exist. So my queue is already getting filled with the values. I'll just show what kubectl pods. Okay, yeah. So we'll see what, yeah, see. So basically now our application is running, which is processing, and there are a few instances which are terminating because we don't need them. So we can set the triggers and all. Now see, because we have trigger, we have more values in the queue. So it actually scaled to more number of pods. And because my maximum is 5 limit, it won't actually go beyond that. Okay. So yeah, I think, yeah. Oh, no, it actually created. Yeah. Ah, okay. I didn't had my limit. Yeah. My limit was on the other one. So by default, there is no limit. I mean, it's actually 100. But yeah, I have to configure 5, so no problem. Okay, just give me a sec. So yeah, I think that was all. Thank you, everyone.